Hello, I'm Matthew Groves. Welcome to this developer demo video on ASP.NET CRUD with NoSQL. In this video, I'll build an ASP.NET CRUD app that connects to a NoSQL database step by step. Now, CRUD stands for Create, Read, Update, Delete, and are the basic set of operations that make up much of the functionality required when working with databases. So it's a good place to start if you're learning to use NoSQL for the first time. The app I'm going to build today is for managing a user profile. Now, each profile will have first name, last name, password, email address, and it will have an amount of onboard credit, like for a cruise line. This application will only consist of a collection of HTTP endpoints, sometimes called a REST API. I'm not going to build a UI, but I will instead use OpenAPI, sometimes called Swagger, to access the endpoints right from a browser. Now, you could also use Postman or curl or other similar tools if you'd like. Now, the endpoints I'm going to build include an insert profile. This is going to create a new profile. Update profile. This will make a change to an existing profile. Get profile to retrieve a single profile by its ID. And search profiles to search for multiple profiles by some criteria. And delete profile to remove a profile from the database. And finally, I'm going to show you a slightly more advanced operation that requires an ACID transaction. And that's going to be transferring onboard credit from one profile to another. So for example, if I wanted to give my daughter some spending money on the cruise ship, I transfer from my profile to her profile, and she can use her wristband or badge or whatever to scan for payment. The source code for this project is available on GitHub at this URL. Now please note, I won't be detailing every line of code that you see in that repository, as this demonstration assumes you have some familiarity with ASP.NET. Okay, let's get started. We're going to set up a new project in Visual Studio. If you're familiar with VS Code or JetBrains Router, these should work fine too. Let's go with ASP.NET Core Web API and C#. And we'll call this ASP.NET Demo. And I'm going to use .NET 5, although .NET 6 or later would be fine too. I'm also enabling OpenAPI support, aka Swagger support. That's on by default. And at this point, Visual Studio is providing a Hello World basic ASP.NET project that includes OpenAPI and all the setup for that. And it's got one controller with one method on it. So let's go ahead and run that. And this is the weather endpoint. There's a forecast, so execute that, and there's the results. It's a series of dates, temperatures, and summaries. Now this code isn't actually touching a database yet. If we actually look in the controller, you'll see it's just pulling some information right from a static array and also getting some random numbers there. So now that we have an ASP.NET project up and running, it's time to explore actually connecting this to a NoSQL database. Now, Couchbase Capella is the fully hosted and managed database as a service from Couchbase. You can sign up for a free trial with no credit card and use that if you're following along with this demo. So you just enter your information here and you get started. And I'm going to show you some screenshots of the process because I've already gone through this already to have my own trial account. So let me go ahead and log into my Capella dashboard here. And I've got one trial cluster in there. And a cluster is a collection of servers that make up one complete database unit, I guess. And inside of this, there are buckets. Inside of each bucket is kind of the equivalent of a database, like a database catalog, if you're familiar with Relational World. So inside this, I'm going to create a brand new bucket. I'm going to call it User Profile. We can specify how much RAM we want to give that for caching. It depends on how much we have available by the resources we've allocated, but for our application, it's not going to be very much data. 100 megabytes is totally fine. We're not going to do any conflict resolution between clusters, so we'll just leave these as the defaults for now. And I've created a bucket. If I click on the bucket name, I will get a list of scopes in that bucket. I can create scopes if I want to. Scope is another level of organization below a bucket, kind of equivalent to a schema in relational databases. We don't need to create a scope, so I'll just click on that. Into the collections, this is roughly the equivalent of a table in relational databases. We'll go ahead and create a collection here. I'm going to call it profile. Okay, so I've got a profile collection. Notice it's not a table, so I didn't have to specify any columns or data types or names, anything like that up front. This is all going to store data that is JSON data. So it's a piece of JSON, a valid JSON markup, and some key that corresponds to that. The key has to be unique. The JSON has to be valid JSON. Beyond that, you can store whatever you'd like to in this database. So now we've got the structure created. I'm going to set up some connection information. So a couple things we need to do. This is the connection string. We need to make note of this. I will blur this out in the video editing because this is sensitive information. But you'll need to copy that into your code later. We'll get to that point. Next thing, we need to manage the allowed IPs. This is a whitelist. So by default, your Capella account will block anybody attempting to connect to it unless you allow that IP address. So I've already allowed mine. Again, I'm going to blur it out for privacy reasons, but you can add your own IP address in here by clicking Add Allowed IP. This will add the IP of the machine that you're currently using to access Capella through the browser. You can whitelist other machines. I'm going to just leave my desktop on there as a whitelist option because that's where I'm going to be running my code from. And finally, I'll go to manage credentials here and create a login and password for the application to use to connect to Capella. And to do that, I'll say create database credential, and I'll give it a username, so something like profile user would be fine, and some secure password. You'll see all the checkboxes there. Turn green, a good password, and then I can choose what kind of access to give to this user. I can specify all buckets or just specific buckets, and I can choose individual scopes in that bucket and read or write access in that bucket. So I could just go all buckets, all scopes, and read or write to all of them. I'm not going to create that because I've already created one in advance. It's here called profile user. So at this point, I've got a connection string, I've whitelisted, I've got credentials to log in, I've got the structures in place. So we're all done setting up Capella here. Let's go back over to Visual Studio. And inside Visual Studio, we're going to open up this app settings .development JSON file. This is where you would put connection strings and other flags and configurations for your application while it's in development. So I'm going to go ahead and add a section here for Couchbase. And this contains all the information I'm going to need to set up Couchbase within ASP.NET. So bucket, scope, and collection name, we already covered those. Connection string, I mentioned that. Username, profile, yes, we created those already. These last three flags here are necessary to work with Capella when not using a certificate. So if you'd like to learn more about certificates and how they work with whatever operating system you're using, please check out the Couchbase documentation because it's different depending on if you're on Mac, Windows, Linux. But for this short demo, I'm just going to leave these flags as is and just go without. The next thing I want to do is I want to create a C# class that's going to correspond to those configuration items. So I'll create a new folder here and call it models. And inside models, I'll create a class. I'm using a tool called ReSharper to take some shortcuts for me, but just creating a plain old class here, Couchbase config. And I'm going to put a bunch of fields in there that match up to all those app settings that we just saw. So same things, bucket name, scope name, collection name, connection string, username, password. These three, I'm not going to be actually referencing them in the code. I'm just going to pass them directly on to configuration, but they do have to be here. And next, I'm going to add a few libraries from NuGet to this project. So there's a lot of ways to do this. I just like to use the UI. I'm going to start with Couchbase Net Client. This is the .NET SDK for connecting to Couchbase. The current version, the current release is 3.3.1 as I'm recording this, but there are often new releases, so don't be surprised if there's a higher number on there. Go ahead and install that. Yes, that's fine. Make sure to read these terms and licenses and such. The other thing is dependency injection library. This is technically it's optional, but it makes it very easy for us to integrate Couchbase with ASP.NET to manage those connections. So I'm going to go ahead and install that as well. Yeah, those are all Apache 2 license, I believe. And finally, I'm not going to use it right away, but I do want to, Couchbase transaction. I do want to add the Couchbase transactions library. This is going to be used later for that ACID transaction endpoint that I mentioned to transfer credit between profiles. So I'll go ahead and add it now just because I'm already here in NuGet. All right, so let's go ahead and go to startup and start to make some configuration changes to the code here. So in configuration services method, the first thing I'm going to do is I'm going to set up the configuration to read from the settings in appsettings.json. The way I do that is by saying services.configure and the class that I defined and the section of the configuration code where it is. And I'm going to add this namespace. JetBrains ReSharper's found it for me, but right there it's the models namespace in my project. Next, I'm going to add the Couchbase configuration, and it's just another services.add Couchbase. This is the extension method that came with the Couchbase dependency injection library, and this is again the configuration section from app settings. And I'm going to add that namespace as well, which is Couchbase extension dependency injection. All right, and everything else can remain as the default for now. That's fine. Let's scroll down here to the configure method. One more thing I need to do here with Couchbase is that when ASP.NET actually shuts down, when the application stops, we need to make sure to clean up and close any Couchbase connections that are still hanging around. So I'll go ahead and add iHost application lifetime as a parameter here. ASP.NET will know how to handle this. It'll populate it automatically. And one of the events we can trigger on with app lifetime is application stopped. So whenever the application stopped, this event will occur, and it will execute everything that's been registered to it. And we just have the one anonymous function here that's going to get the iCouchbase lifetime service and then call the close method on that. Now, I know this is a lot. This is something you have to do basically once a project, and I always forget this here, this name of this interface and the name of this interface, so I have to look them up in the documentation. But once you've done it, it's done, and it'll work from that point on. Everything else in the configure can remain as the default. So at this point, the application and database are all configured, and I'm ready to start writing some endpoints. Now there's already a controller with an endpoint for the weather forecast, but I'm going to create a second controller for the profile here. We'll create another class here called profile controller. And it needs to be inheriting from the controller base class, which is in the ASP.NET Core MVC namespace. I want to put an API controller attribute on it because it is for APIs, and I want to give it a route. So everything coming into this controller to this endpoint is going to use this route right here, unless we tell it otherwise. And this can be whatever you want it to be, but this is a pretty standard route for APIs. Within this brand new class, let's start with a constructor, ctor and tab. I think that's a little shortcut from Visual Studio, maybe from JetBrains. Either way, create a constructor here. Now that dependency injection library makes a couple of objects available to me here in the constructor. I just need to add them as parameters, and it'll automatically inject them. So I'm going to ask for two things. One is a cluster provider, and one is a bucket provider. And these are objects that will give me cluster and bucket objects when I need them. I'll show you what those do in a minute. I also want the Couchbase config object because it contains the bucket name, collection name, and so on, which is what I'm going to need in this code. I'm going to use the iOptions pattern for this. Couchbase config, and I'll call that config. And that is in the models namespace. And then inside of this, I'm going to just take these parameters that are passed in and assign them to private read-only fields. This is just another ReSharper shortcut. Actually, I don't want config. I don't want to store the iOptions. Let's just store .value, and we'll store the config itself directly. That'll be fine. Okay. So let's start with the very first endpoint. And this is one to create a new profile in my database. So assuming we're starting from 0 profiles, let's actually create some. So let's just use HTTP post and public async task action result, and we'll call it post. And there is our first endpoint. As a parameter, I need information about the profile. So we're posting some data via HTTP to this endpoint, and I need to get that data and then save it to the database. So what I'm going to do is I'm going to create a profile create request command object, and that's going to store all the information needed for this endpoint. I haven't created that class yet, so let's go over to models and create a class there, call it that. And what's going to go into that model is all those things in the profile: first name, last name, email, password, onboard credit. And so there we go. And that's the parameter is request. And I'm going to just go ahead and mark that as from body. So we're going to expect it in the body of the request, just to be explicit there. To interact with the database, we need to start by getting a bucket object. So we can say bucket equals, and I'll use bucket provider. It has one method to get the buckets asynchronously. Everything's going to be asynchronously here, so I need to say await. Get bucket async, and then the bucket name, which I know from the config is there, bucket name. And there we go. So I can start doing operations on the bucket. But I actually want to put data inside the collection that's inside the scope that's inside the bucket. So we need to go one step further here and say collection await, and I'll say bucket dot collection async, and I have the collection name in the config right there. So at this point I have the collection. I can start doing key value operations, inserting data into that collection. Now, where's the scope? I skipped past the scope here. I went from bucket right to collection. Well, the reason is that if I'm just using the default scope, underscore default, I can skip right past that, and the API will assume that I mean you just want to go right to the collection in default. So that's fine. Next thing I need to do is I need to say use the collection object to insert data. I need to specify a key and then some object here. And this object is just a plain C# object. What Couchbase is going to do is take that object and serialize it into JSON. So we don't have to pass a raw JSON string. We can just give a C# object, and Couchbase will do the rest. And then we give it a key. It has to be a unique key to store so we can look up that data later. Now, what should I actually pass in here for the key and for the object? Well, I could just pass in the request here, store the request in the database, but I'm not really trying to store a request. I'm trying to store a profile itself. So these look very similar right now. It's the same data at this point. But as this app evolves, as it changes in the future, that may not be the case. And plus, there may be some validation and logic that I want to apply to the request itself. So I'm going to create another C# class called profile. And this is going to represent the actual model of the data that's going into the database. So I'm going to paste some fields into here, including a GUID. So I've made a decision here to use a GUID as a key. I've also made a bad decision to store password as plain text. And that should be hashed with bcrypt or some sort of hashing algorithm, but it's fine for now. So I've got this request object, and I've got a profile type. How do I get them to map to each other? Because this is the data that's coming in. I want to actually save this object here. So there are some tools out there that do this automatically, but let's just start simple. I'm going to create a method inside of profile create request command called getProfile. And it's going to return a profile object, as you see here. And also notice that it's creating the GUID for us. So the actual request command, we're not taking in a GUID from whoever's making this HTTP request. We're going to assign the GUID ourselves. So this is where I'm doing it right here, inside the code. And this would also be a good place to check to see, maybe hash the password, for instance. Or maybe check to see that onboard credit is valid. But we're just keeping it really simple right now. So let's back to the endpoint here. I'm going to create a profile object by calling this method. So we'll say profile equals request dot get profile. And that's going to return a profile object. Put profile right there. And I also have a key now that's been generated, a profile object, profile.pid. Needs to be a string for Couchbase. So we decided to use GUID, but Couchbase accepts anything as a key, so we need to put as a string here. And finally, I'm going to return created here. And I'll just copy and paste this because it's a URL. return a created message here. This is just a method of the controller base class. This is the URL, the resource identifier, if you will, for this profile. Now, I haven't created this endpoint yet, right? But we will create one, and this is how you get to it. So if anyone created this profile, they would get this back as a result. They can immediately click on that and go right to the profile. And the profile itself, I'm just going to echo back to the response here. All right, so let's go ahead and compile and run this. All right, over here in Swagger, you see a new profile group showed up with a single endpoint. And I'm going to try it out. This takes in some JSON here. I'm just going to put in some of my own information. Matt Groves, Matt at email, my very secure password of foo, and I'll start with $500 of onboard credit. Go ahead and execute. Okay, and I have 201 returned, and there is the profile being echoed back to me. So we're all set. Now let's go back to Couchbase Capella briefly here. Let's look at that user profile, bucket, default scope, and profile collection. There is some data now in my database. Now, this is a document. It's kind of like a row of data, except it's JSON. If I click on this key here, you'll see that it comes up with the JSON that's being saved there. I didn't have to specify all those fields and names, just that it has to be JSON, and our Couchbase SDK takes care of that. And now I have the ability to, if I want to add more fields, I can go ahead and do that. And I can do that on a per document basis when and if I need to. One thing else to point out here is that this PID stores the same information as the document ID of Couchbase. There's nothing special about PID. It's just a field that I made up. It's just the same thing as the first name field, right? It's just I can put any fields I want to in here. So what I probably should avoid then is keeping this PID inside the document and just rely on the document ID, which by the way is also part of the metadata right here. I should just not save that to the database as a separate piece of data. I should just leave it as the document ID. And there are some tricks we can do. We can put some attributes on our profile class to say don't serialize the PID. Just use it as the document key. But we're not going to go into that for now. Just notice that it's something that you probably want to avoid, having duplicate data in your document and your key. Let's create the get endpoint next. So I know from creating this last endpoint right here that the ID is going to be passed in. So let's go ahead and make this a get. And I will say public async task iAction result get by ID as well. Call it. And I know that I want GUI to be passed in as the parameter there. And I know it's coming from the URL because I just see it up here. So I'm going to call it just explicitly from route. The other thing I need to do is I need to make sure that the get here puts the GUID into the ID field. So I'm going to mark this as ID GUID. And there we go. We're ready to write some code. Inside of this, I'm going to need the bucket and the collection again, the same way as before, bucket and collection. I'm going to use a different method than insert, obviously. I'm going to say result equals await collection dot get async. And I'll pass in the ID. It has to be a string, of course. And this line right here is actually getting that data from Couchbase that matches the ID. Now this method actually returns an iGetResult object here, not the profile class. So in order to get that, I need to say result.content as profile. Now remember, Couchbase is storing JSON data. It's not storing C# objects. So we have to say, well, I want this piece of data, but I want you to give it to me as a C# object. This also provides flexibility, as I could potentially serialize the same document in Couchbase, the same JSON, to different types in .NET. So for example, I've got a profile here, but what if I had a Carnival profile or a Royal Caribbean profile, and so on. So let's go ahead and return this object with an OK. It's just another method from ASP.NET, and that will return the data. Let's try it in the browser here. Okay, I'm going to create another profile just to, because I'll need it later, and I'll put in my daughter's information. Emma Groves, different email address, another very secure password of bar, and $0 in onboard credit, because I know she's going to spend it right away on any sort of cute plushies or art supplies she can get her hands on. So we'll give her 0 for now and execute this. And now Emma's been created as another profile. So let's get the GUID from her and look her up with our new get endpoint. And there we have it. You can see Emma's being returned to us. The full profile is being returned with all the information I just put in. Let's go back to the code here. Now, before I continue, you may notice the lack of any validation or error checking or logging in this code. I'm skipping all of that for the sake of brevity. But if you check out the full sample on GitHub, you'll see that it's a more robust implementation than I'm writing here. It's got logging, error handling, specifications, integration tests, validation, and so on. It's all in that code. So definitely check out that full sample on GitHub. Next thing I want to do is create an endpoint that can return multiple profiles. So we're still in the R here. We've got C and R. I want to continue to expand on the R a little bit because we can operate on data in Couchbase in multiple ways. So let's create another get method. And it's going to use a different URL here than the one we specified at the top. So I'm going to say profiles with an S. We want multiple profiles. So another async method. Whoops. Got a little ahead of me there with the guessing what I wanted. Okay, I'm going to call it list. And here's the endpoint that we're going to return a list of profiles that meet some criteria. So once again, I'm going to put an object on here with those specifications. Profile list, request, query. That'll probably be fine. Don't have that yet, so I'll create that class over here. And it's going to have one field for now, which is a search string. So this is going to match the first name and or last name of the profile that I'm searching for and return anything that matches that. Really simple to get started. It'll definitely be something to expand on later. But for inside of here, we're going to need to get the cluster actually from the cluster provider. So give me the cluster. Now, why am I using cluster here? It's because I'm going to use a SQL query. And a SQL query can join and interact with data from multiple places, multiple collections, scopes, and buckets. So at the cluster level is where the query API lives. That's why I'm getting the cluster object there. But speaking of SQL, we're going to go ahead and actually write some SQL now. It's actually SQL++. So let's go over back to Couchbase Capella. Over here in Capella, you can see we've got 2 pieces of data now because I created my daughter's profile in there. But what I want to do now is I want to go to Tools and then Query Workbench. So if you've used SQL before, this should be very familiar to you. And SQL is the most popular language for querying data in the world. So I'm just going to write a very simple SQL query to start with. We'll say select p.star, so select everything from, start with user profile, which is the bucket, default, which is the name of the scope, and then profile, which is the collection. I'm going to alias that p. So this will select all the fields from every document, every piece of data in that profile collection. But I want to filter it down to match a search string. So let's say where lowercase of first name is like, and I'll put my last name in here, Groves, or lower p dot last name is like, and this is a wildcard match of Groves. So that % is just standard SQL syntax meaning wildcard, and like means I want you to match anything that has Groves in it. So the beginning, end, or in the middle, as long as it's got Groves, I want you to match that. So this will select anything where the first name or last name matches Groves, which is my last name, but we'll check the first name as well. Oh, one more thing. These little backticks on here around user profile, that's the top left of your keyboard. Those aren't necessary unless you use special character in your name, like dash or something, in the name of the collection or the bucket. But it's okay to use them all the time, so we'll use them here just to be safe. This is a relatively simple query. I'm not going to use any more complex SQL than this today, but for the record, Couchbase's SQL++ implementation includes all the CRUD operations you'd expect, common table expressions, joins, aggregation, window functions, ACID transactions. Everything you'd expect from SQL is all here in SQL++. And then the ++ stands for the other things you might need to do because it's JSON data. Another point here to make is that this kind of text search is really better suited for a text search engine and not really for SQL. Fortunately, Couchbase has a full text search engine built in. I'm not going to cover that in this demo, but you can create text searches on the same data. You don't have to copy it or replicate it elsewhere. You can do those searches right here in Couchbase. And you can also do them within SQL. So I can combine SQL queries with text search to get the best of both worlds. Okay, let's execute this query. And what we're going to get is, I've got some syntax error here. Oh, I've got a comma here. It should be a period. All right, execute this. Okay, now I've got a different error message. And let's read this message, see what it says. No index available on key space. So key space is just a bucket scope or collection, whatever I'm querying on. And this is the key space we're trying to get from. Yep. No index that matches our query. All right. Use create primary index on, this profile key space. Whoops. To create a primary index. Or check that your expected index is on. So I haven't created any indexes yet. And by default, if you don't create any indexes, most queries in Couchbase are not going to execute. It's because there could be a lot of data in here. And if we're going to scan every piece of data, that could be a very, very poor performing query. So we want to make sure to have good indexes in production. Now, since we're just doing a quick demo, I could throw in this primary index. This will enable SQL queries to scan all the data. But let's do something else. Let's do something called the Query Advisor. I'll click on this Advice button here. And this is going to suggest some indexes that I might create that would be good for performance. It's not always going to be 100% perfect, but let's go ahead and put these indexes in here. You can see this is indexing the lowercase of the first name field, and this is index of the lowercase of the last name field. So those make sense as indexes. We'll create that first one and create the second one. Just both the suggestions. And then I'll go back to the query, execute, and now it is running. And if I look at the query plan, I can zoom in here and see that, hey, actually those indexes I created, those are being used here. And you can see all the other steps of the query, what takes the most time, etc. But there's the results. It's returning, since I searched Groves, it's returning both myself and my daughter. I could change this and say, well, I want to search for Matt instead. Find me everybody that has Matt in the first or last name. And that's just going to be one. All that data I have in there for now. So then I need to take this query and put it into the ASP.NET endpoint. So I did the cluster object already. Next I need to create a string. And I'm just going to kind of paste that in from the workbench there. Now, if you're not familiar with this string syntax in .NET, don't worry. This @ symbol here just says I want this string to be able to span multiple lines. So I don't have to put in a bunch of extra quotes in here. And the $sign says I'm going to replace some things in the string with some tokens, and I'll show you that later on. This isn't going to quite work as is, this query, because it's hard-coded to Groves, and I want to pull that from the request object. And also I want to make sure anything I give to this query is lowercase ahead of time. Otherwise, I have to put another lower function here, and I could do that, I guess, but we'll just do it this way for now. So I'm going to slightly change this to introduce a SQL parameter. So I'm saying this is a string concatenation here. So put the search token in there between those wildcards. And I'll replace this search token with something called SQL parameterization. Now, it's always a good idea to parameterize SQL statements to avoid SQL injection attacks. And this is true no matter if you're using a relational database, Couchbase, or any sort of SQL. You should always parameterize those tokens there. Another thing that's hard-coded is the bucket name, scope name, and collection name. That's not likely to change very often, but it's still a good idea to get that from config instead of hard-coding. And this is where I'll use the string tokens to just put this syntax in here and say use the config inside that string for those names. Okay, so then I've got a query here. Let's feed that into the cluster with the cluster.query async. I'm going to map all those results to profiles. and put the query in there. And there we have it. So that's going to run this query and return results as a collection of profile objects. But I didn't actually specify my parameters yet. This request is still not being used. So let's go ahead and create this lambda. You can call it whatever you want. I'm just going to call it options. It's complaining here because I don't have the right namespace. So we'll go up to the top here. It's a good chance for me to review which namespaces I've included so far, just in case you're not using ReSharper, you're doing this manually. You can get to see which namespaces I'm using so far. Okay, and then inside this lambda, I'll say options.parameter. The name of that parameter is search, and the value I want to give it is request.search. I'm going to say to lower, just to make sure whatever string is passed in there is going to be lowercase, which will match, will best match this. Okay. The results returned from this query is in an object called iQueryResult. An iQueryResult has a field called rows, and that contains the actual data. There's other data in result, other information in results, like any errors or metadata or so on, but I just want the data itself. This is actually a async enumerable object of profile, which you can do a lot of interesting things with async enumerable, but just to keep this simple, we're going to say, just give me that in a plain old list. And then at this point, I have a list of profiles. It's a plain old C# list of profiles. That's good. And I'll return that with an OK. So there we go. Now I've got this endpoint that will perform the SQL query and return the results to me. Back over here in Swagger, got this new endpoint now, and let's try it out. Let's try it out with Groves. Oh, I think I messed something up. So my mistake, this should be from query, and this should actually be asynchronous. This should be await, because this is an asynchronous method. So let's try this again. And into profiles endpoint, try it out, Groves. And there we have it, 2 results, one for Emma, one for Matt. I'll change this to Matt, and there we have just 1 result for Matt. Now, as you might imagine, as you have more and more profiles in your database, the results returned from an endpoint like this could get very, very large. So it would be a good idea to introduce some form of paging to this endpoint to return, say, 10 or 50 results at a time, for instance. I'm not going to go into that in this demo, but the GitHub example makes use of limit and offset keywords in SQL to get those paged results. But the key thing here is that we're using SQL for this endpoint because we're querying on something other than the key of each of these documents. We're querying on some property of these documents, some secondary index of these properties. Okay, let's get now to the last 2 endpoints. Create, update. We're going to create the update and delete endpoints. So these are going to follow very similar patterns to what you've seen before already. For update, let's call it HTTP put. And we'll do a public async task action results. We'll call this one update, I suppose. We need another class here, profile update request command. And we'll just take this and create a new class. Whoops. Did I create one called class 1? I did. So we'll just change the name of this real quick to profile update request command. Yep. Change the file name too. Yep, that's okay to make mistakes sometimes. All right, and inside of this command, it's going to be very similar to the create command from before. The main difference being right now is we have this GUID in here. Because we're going to operate on an existing piece of data instead of creating a new one. So we have to go ahead and specify that ID. We expect that ID to be specified to this endpoint. Okay, and we're going to use that as a parameter, and I won't forget this time to put on the correct attribute there for from body. Inside of this, we're going to go to bucket and collection again. Put those right in here. We have the bucket and collection. I'm going to use collection.replace, and we can specify the type if we want to there. of profile, and it's going to need an ID again, so we can get that from the request. PID, toString, and the actual object to replace it with is, do we put request in there? No, we say request.getProfile, because I want the actual profile object. Again, doesn't really do much right now, but we could put some validation in here to say it must be a valid ID, it must must have the correct onboard credit, etc. But don't have that right now, but might have that in the future. And after that's done, I'll just go ahead and return an OK of the request object itself. Just echo that back to whoever's requesting it. Okay, and then let's go to delete. This is going to be another method here, public async. Result, and I'll just call this delete. Why not? Inside delete, I don't need the whole piece of data. I just need the GUID, just the ID of the profile you want me to delete. And so if I'm going to do that, I'm going to need to specify that it's a GUID up here. All right, and this will be from the route, so actually from the URL, just like the get, or just like the get by ID. Okay, inside of this, again, bucket and collection. And we'll just go ahead and use collection.remove and pass in that ID. It has to be a string. And that's it. Return and OK. Yep, everything went fine. I deleted that object from the data. Let's go try these out in OpenAPI, back in Swagger. Let's just go through the whole series of endpoints here just to show the whole process off, because we've created all the CRUD endpoints at this point. We've got a create, we've got two different reads, we've got an update and a delete. So let's create a brand new one. We'll call this one delete me Groves. You can see it's got delete and me Groves. Email is just delete. Another secure password of Baz, and he's got 350 in onboard credit. Go ahead and execute that to create a new profile. We've done that before. Let's go ahead. Oh, we need to get the ID here. Save that for later, and we'll go ahead and get it with that ID using the get endpoint. There's delete me Groves again. Let's make a change to it. Looks like that email address was not quite right, so let's go ahead and make a quick change. I'll just paste in the whole thing here. Changing the email address to delete@mail. Notice the ID has to be the same as the one we got out for this profile. Execute that. Made the change. Now let's go to a list. Search for Groves again. We should get 3 profiles. And we do. There's delete me Groves, Emma Groves, and Matt Groves. I want to delete me Groves is our last thing we do. I'll put ID right in there and delete it. Success. Back to profiles. Execute. We should only have 2 this time, and we do. Emma and Matt. So there we go. We've got all the CRUD points created. All the CRUD endpoints are functioning. They're working. And we've got enough to get started with our database. But I want to show you something a little more advanced to just wrap up this demo here. Because you may have heard a lot of things about NoSQL. And for instance, it doesn't have transactions. And that used to be true a while ago. But here with Couchbase Capella, ACID transactions have been supported for some time. So I'm going to create an endpoint to demonstrate that. Let's get back to our controller here, and I'm going to create another post endpoint, so we'll have to have a different route for this because I already created one post endpoint. And this will be another function, action result, call it transfer. And for transfer, I want to transfer onboard credit from one profile to another. So we're not strictly in CRUD anymore. We're doing multiple things. We're doing reading and updating. And we want to do those all in one endpoint. So it's a little more complex. Let's create a profile transfer credit let's say request here, just like we've been doing all up the endpoints here. Create another model to specify what goes into that request. And I just want 3 things. I need the GUID of the profile that we're going to transfer the credit from, the GUID of the profile we're going to transfer the credit to, and then how much is the actual credit going to be. Let's go back to the controller. So once we've been given that information, I want, again, the bucket and collection. Now let's create something called a transaction object. Use the transactions.create. That should be in the Couchbase transactions namespace up here. Transactions.create. And I'll just give it the cluster. Now I could have just gone and got the cluster from the cluster provider instead of bucket provider, but I do need this collection as well. So I'll just keep that there, say bucket.cluster, that's totally fine. Next I want to run a transaction. And the way I run a transaction is I'm going to say await, because it's going to be asynchronous. TX, the transaction object, run, it's going to also be asynchronous. And this expects a func inside of here, asynchronous func specifically, which has one parameter. I'm going to call that CTX for context. And that needs to be a lambda function. So we got a stray parenthesis there. Okay. So that means any code inside of these brackets here is going to consist of the code that makes up the transaction. And we'll use this CTX that's being passed in to do those operations. Now, if this looks a little weird, that's okay. I mean, this is maybe a little bit unfamiliar C# syntax with asynchronous and the lambda, and we've got this transaction running an asynchronous object. But this is just what you need to wrap the actual code in. Inside the transaction, we're going to do three things. We're going to get those two profiles that are specified in this request. We're going to then modify those profiles here in C# objects to transfer the credit. And then we're going to replace those profiles with the new modified versions. And the reason we're doing this in a transaction is because it needs to be both these things. We need to all three of these things need to happen. So we need to transfer the money by subtracting it from one and adding it to the other. If for some reason there's an error and we only subtract it from Matt, then money just disappears. Onboard credit disappears and doesn't go anywhere. If something goes wrong and we only add it to Emma, then we're creating money out of thin air. Neither of those two situations are acceptable. So we need to make sure that both of them happen or none of them happen if something goes wrong. So the first step is we're going to get. This should look similar to the get from before. I'm just saying give me the result from the get. I got to specify a collection in this case because I'm using this transaction context, CTX object. And I'm using CTX object because it needs to keep track of all the things I'm doing with the database so that it knows if something goes wrong, how to undo what I told it to do. And just give me the ID of the person I'm transferring from. And I'm going to serialize that to a C# object of type profile. And do the same thing here for the to profile using the to ID. All right. So the only difference here is the CTX that we're using and have to pass in collection. Step 2, this is probably the easiest step, I guess, to demo, is I'm going to move the amount from one to another. So I'm going to create a special method to do this. Let's go over to this profile class. You don't have to put it here, but I'm just going to put it here for now. A method that's going to take a given profile I want to transfer to and an amount, and then subtract that amount from my profile and add it to the to profile. Now, this is not a very good implementation because what if a negative amount is specified? What if the amount is higher than the existing balance? So it needs validation for sure. But I'm going to leave that as an exercise for you to take on. I'm just going to focus on the database CRUD. Back to our transaction. Last thing we need to do is replace the data in the database with the new C# objects that we've made changes to, where we've done the transfer to. So again, it's just a replace. I'm going to pass in this result here that I got from the get and pass in the new object I want to replace it with. So again, we're using the context here, the transaction context, to do that replacement. Again, so it can keep track of everything we're trying to do along the way, so that if something goes wrong, it can take us back to the consistent state from before. So we're not creating any money or erasing any money from existence. Finally, I'll just wrap up and say context.commit. This is technically optional because once this function is ended, it will automatically commit. But sometimes you may want to be explicit and say, yes, I want to commit here. I could also say rollback, which means transaction over, but don't save any of those changes. And that's why it's important to use CTX here, so it can keep track of what not to save. So if it's a negative amount or it's invalid amount, that would be a time to roll back. Okay. And then we'll return OK, because the transaction is successfully completed and we're in good shape. So let's go back to the Swagger. Got this new transfer method here, but first let's get a list of those profiles in there, because I need those IDs to make a transfer. So we started with Matt having 500, Emma having 0. We're going to transfer from Matt, so let's take this ID down here, transfer from Matt to Emma. This is Emma's ID. Let's copy that one, paste it right here. That's the 2 ID for Emma, and $50 should be enough for souvenirs and snacks and whatever she wants today. Go ahead and execute that, and it's succeeded. So let's go back here and run the search again, and we should see the correct amount. So Emma is up $50, and I am down $50 to $450. So I've successfully made that transfer. So that's it for this demo. I've just built a CRUD app using NoSQL, SQL++, and ACID transactions. Are you ready to give it a try for yourself? So sign up today for a Couchbase Capella trial. No credit card needed. You can get started doing the exact same thing that I did here today. If you have questions or you need help or advice, there's a couple places you can check out. One is the Couchbase forums. That's forums.couchbase.com. You can post your question there or start a discussion and get some answers from many Couchbase engineers and other Couchbase users in the community. Or you can check out the Couchbase Discord for a more interactive, closer to real-time approach, just like a chat. And you can go to the URL on the screen here, and those same types of people are going to be hanging out in there. People in the Couchbase community, Couchbase engineers, people who can help you and discuss things with you and answer your questions. And finally, you can find the full source code for this project on GitHub at the URL on your screen right now. This is a more complete version of the demo that I showed you, as it includes validation, integration tests, which are very important, error handling, and so on. Thank you very much for watching.